Good afternoon, I am Mr. H. Thank you for joining me for this video. We have a single redox reaction which is unbalanced, a reduction oxidation reaction which we have to balance properly in an acid solution. We will look at in a very similar manner in another video the same item but with regards to a basic solution. Here the goal is to balance this with regards to acid solution. We will do this in a step-by-step manner. The first thing you want to do is determine what is being oxidized, what is being reduced. Remember, oxidation is the loss of electrons, reduction is a gain of electrons. You have over here an iodate, you have an iron in terms of a species, then you have iodine and then iron 3+. When you're looking over here at this, oxygen over there is always going to be -2 times 3 will be -6, and iodine here is going to be +5 to give you that net -1. So iodine is +5 over here. Here iodine on the other side is a 0. Iodine is reduced, and I'm going to put a little R next to it because iodine is being reduced, and you're seeing the oxidation state go from +5 to 0, meaning it gained electrons. When you're looking at iron, it's easy. You're seeing a Fe2+ to Fe3+. You're losing an electron here and you're gaining a positive charge. So this right here is being oxidized. Now we have everything here clear. We now know based on the oxidation states that iron was oxidized, it lost an electron, and iodine was reduced, it gained electrons. So what is our oxidation reaction? It's this right here, Fe2+ to go to Fe3+. We're not worrying about the direction of arrows or any of that, we're just balancing here. What's my reduction reaction? Based on what I see, it's this going to iodine. Now what we have to do is make these into half reactions, and I can do that. And the first thing I want to do is focus on the second reaction and start balancing the non-oxygen terms, and that's the iodine. It has to be balanced. The iron is already balanced, so there's not much to do. Now that I've balanced this, I have to focus on oxygens. We'll focus on the electrons and the charges at the end, but here we're just balancing elements and atoms. I have 6 oxygens, therefore I must generate 6 oxygens here, but by means of water molecule. You see I've got 6 oxygens, but by putting a water molecule I've added 12 hydrogens here, and I gotta bring 12 hydrogens here, which in an acid solution I can only do with regards to this hydrogen ion. But now you've seen that the elements and the atoms are balanced, but the charges are off. When I'm looking here at the top, Fe2+ to Fe3+, I can balance it out by throwing in an electron. When I'm looking over here, I'm not balanced in terms of charge. I have a +12 here, and then I have a -2, which is a net of a +10. The only way I can balance this is if I throw in 10 electrons on this side, and I will do that, 10 electrons, and now everything will be balanced in terms of charge. But by balancing these individually, I still don't have an equality of charge based on the right and the left side. Here, if I look at it in terms of electrons, and here, when I look at it in terms of electrons, the electrons are off. I would hit all of this by a 10 because that'll give me 10 electrons here, and then I'll rewrite everything. I have 10 Fe2+, giving me 10 Fe3+ plus 10 electrons. I don't have to do anything over here other than rewrite it. 10 electrons plus 12 hydrogens plus 2 iodates. I have this iodine molecule diatomic, and then 6H2O. Now what can we do? We can certainly cancel this, and then we can combine everything over here. When I combine everything with what remains, I'll have 10 Fe2+ here, I'll have 12 H+, I have 2 iodates, polyatomic anion here, I have 10 iron 3+, I have an iodine, and then I have 6H2O, and this should be my balanced reaction, but we have to check it. We'll check it individually. I have 10 irons, I have 10 irons, so we're good. I have 12 hydrogens, I have 12 hydrogens, we're good. 6 oxygens, 6 oxygens, 2 iodines, 2 iodines. Now we have to check the charges. On this side I have a +20, +12, -2. What is this? A 32 -2. I'm having here a +30 as a charge. Here I have 10 times 3 +30 as a charge, so the charges are good. Everything is balanced, the charge, the atoms, all of that. And that's how you go about balancing a reaction in acid. When you're balancing a reaction in acid, in the end you should be seeing something like this: hydrogen ions. You shouldn't be seeing any hydroxide ions, and it's okay to see water molecules in your balanced reaction. Just remember this: when you separate and identify your oxidation and your reduction half reactions, focus first only on balancing the non-hydrogen or the non-oxygen species, anything else other than those. Then you balance the oxygens by bringing in water molecules. then you balance the hydrogens by bringing in the hydrogen ions, then you start balancing the charges, then you try to cancel out the electrons by multiplying with coefficients. You write everything in a single balanced reaction, and then you check at the end to make sure the charges on both sides are good. We have plus 30 here, plus 30 here, so everything is good, and this answer should be right. And that's all I wanted to present you. Thank you. Have a good day.